So what I want to show you next is a video of 20 of these little robots flying in formation. They're monitoring their neighbor's position. They're maintaining formation. The formations can change. They can be planar formations. They can be three-dimensional formations. As you can see here, they collapse from a three-dimensional formation into a planar formation. And to fly through obstacles, they can adapt the formations on the fly. So again, these robots come really close together. As you can see in this figure 8 flight, they come within inches of each other. And despite the aerodynamic interactions with these propeller blades, they're able to maintain stable flight. Another application I want to show you, again, this is in our lab. This is work done by Quentin Lindsay, who's a graduate student. So his algorithm essentially tells these robots how to autonomously build cubic structures from truss-like elements. So his algorithm tells the robot what part to pick up, when, and where to place it. So in this video you see, and it's sped up 10, 14 times, you see 3 different structures being built by these robots. And again, everything is autonomous, and all Quentin has to do is to give them a blueprint of the design that he wants to build. So all these experiments you've seen thus far, all these demonstrations have been done with the help of motion capture systems. So what happens when you leave your lab and you go outside into the real world? And what if there's no GPS? So this robot is actually equipped with a camera and a laser rangefinder, laser scanner. And it uses these sensors to build a map of the environment. What that map consists of are features like doorways, windows, people, furniture, and it then figures out where its position is with respect to the features. So there is no global coordinate system. The coordinate system is defined based on the robot, where it is and what it's looking at. And it navigates with respect to those features. So I want to show you a clip of algorithms developed by Frank Shen and Professor Nathan Michael that shows this robot entering a building for the very first time and creating this map on the fly. So the robot then figures out what the features are, it builds the map, it figures out where it is with respect to the features, and then estimates this position 100 times a second, allowing us to use the control algorithms that I described to you earlier. So this robot is actually being commanded remotely by Frank, but the robot can also figure out where to go on its own. So suppose I were to send this into a building and I had no idea what this building looked like, I can ask this robot to go in, create a map, and then come back and tell me what the building looks like. So here, the robot is not only solving the problem of how to go from point A to point B in this map, but it's figuring out what the best point B is at every time. So essentially, it knows where to go to look for places that have the least information, and that's how it populates this map.